That's right, today we're going to talk about galaxies. Galaxies in the universe. The largest things in the entire universe. That's what we're going to talk about. These amazing galaxies that are far, far away. Up in space. Galaxies. Billions of stars. Maybe hundreds of millions of stars gathered together in groups that we're going to talk about today. So let's decide what we can learn today. So the galaxies are amazing. They're these huge clustering of stars, the suns that we've been talking about that are up in space. All right, so let's talk about this here. We are a member of the Milky Way galaxy, a large spiral galaxy in the universe, okay? But there happened to be more than one galaxy. Actually, astronomers didn't really necessarily believe this. They didn't know that there were lots of other galaxies until they began to probe deeper and look further. It was a controversial thing whether or not there was just one galaxy, the Milky Way galaxy, or there were many. But now it's pretty undisputed that there are lots of galaxies. In fact, in the neighborhood of millions of galaxies. And as we look at galaxies, we discover that there are different varieties of galaxies. There are spiral galaxies. There are egg-shaped galaxies. Now, the egg-shaped ones are called elliptical. And there are irregular ones. Other differences, galaxies aren't all the same. They also have different types of gases. So some types of galaxies have different kinds of gases, and some have different amounts of dust in them. Okay? It tends that the galaxies themselves even tend to cluster together. And they appear to separate from each other, primarily due to the expansion of the universe, which we'll talk about later on. And the interesting thing that scientists don't understand is why is there such diversity of galaxies? Galaxies look so different. They're amazing in their diversity in terms of the number of different kinds of galaxies and how they look. And it's pretty cool, really. So, all right. So what is a galaxy? Let's just kind of get this defined. A galaxy is an immense... Immense? What does immense mean? Immense means big, really big, or really big, or really, really, really big. Okay. Yeah. Isolated cloud of hundreds of millions to hundreds of billions of stars. And vast clouds of interstellar gas. Remember, we learned that interstellar gas is the substance that stars are born out of. Okay? So that's, yeah. Each star moves in its own orbit, guided by gravity, generated by the other stars in the galaxy. So if you look at our picture over here on the right, we have a galaxy, and here may be a few stars, but they're moving because of gravity. Notice in the center of a galaxy, we tend to have what we call the nucleus of a galaxy. A clustering of so many stars you can't distinguish one star from the next. Okay. Now, early observations of these galaxies. Well, it turns out that before we had telescopes and such, that the galaxies, first of all, are very far away. So most things that people looked at and said, oh, that's just a star. Turns out some of the things that you see in the sky that are stars are not stars at all, but billions of stars together. They are they're a galaxy. Well, you can only see a few of them with your naked eye. Okay, and what are those? Okay, without the aid of a telescope, there's just very few you can see. So they are. I lost my train of thought here. The Andromeda and the Large and Small Magellanic Clouds. So in the 18th century, Charles Mesner cataloged several fuzzy objects. He was looking for comets, as it turns out. And as he was looking for these comets, it turns out, well, some of these things were not comets, and they weren't stars. They were galaxies. And so one of them was called Andromeda. There's a whole naming system we're not going to get into, but M31, there's ways they categorize them by letters and designations and such. Okay? And then William Herschel and others, they cataloged or mapped the heavens, creating what's called the New General Catalog, or NGC, which included many galaxies. This is kind of the idea is that they decided to change the naming. How do you name a galaxy? They gave them like Carl? No, they don't name them Carl. Or Mr. Bergmann? No, they don't do that. They have a numeric system that helps you understand kind of where it's at. It's not important, but there's a way that you can catalog a particular galaxy, and there's a whole system, the New General Catalog system. And so here are those clouds. You can see those right here that we have pictures right here of. Let me change the color of the pen to white. These are galaxies right here when zoomed in. Now probably like this is an individual star, but right here we have a huge, huge galaxy. Okay, so let's keep looking here. There's different types of galaxies. In 1920s, Edwin Hubble, hence the Hubble telescope, very famous astronomer, demonstrated that galaxies could be divided on the basis of their shape into types and subtypes. And so this is just a cool galaxy. Is that like the coolest thing you ever saw? My gosh. You take a look at that. That is just cool. That's billions, maybe millions of stars all clustered together, and it's pretty, really. Okay, sorry. Get set. So first of all, the first type of a galaxy is called a spiral galaxy. Spiral. We've got the spiral galaxy, and we have the first picture, the one we just saw just a minute ago, right? And then we got another, and they got another. They're all spirals. Spirals, okay. So there's two or more arms winding out from the center. Do you see the arms? Do you see an arm? Oh, there's an arm. Oh, there's an arm. Oh, there's an arm. And this one has arms too. Okay. And then he classified it also with a letter, followed by the S for spiral, duh, followed by the letter, small little letter A through D, to distinguish how large the nucleus is and how wound up the arms are. The nucleus, of course, that's center of the galaxy, like right here. So there's special ways. Well, let's look at that. Well, actually, let's break that up and talk about the second variety of galaxies. They're called elliptical. Ellipses, hence, so they're kind of oval shaped, right? So they're smooth, featureless appearance and a generally elliptical shape. Remember, elliptical is an oval, right? And they classified with the E. What do you think the E stands for? E. Elephant. No, I don't think it's that. Oh, it's elliptical! Ha! E. Elliptical. I'm good, right? Followed by a number, 0 to 7, to express the flatness of the shape. Okay, you'll do this. You have an exercise in class that you'll do that will kind of make you categorize these things. Okay, and hey, here's the scheme. So if I've got a spiral galaxy, the SA, spiral, A, good, okay, has a large bulge and the arms are very tight, tightly wound. Okay, if you get a medium-sized bulge and the arms are not so tightly, it's SB, notice A, B, C, D. And then we have loosely wound with a small bulge, we get the S sub C. And the SDs are large and loosely wound. For ellipticals, if it's almost a circle, a sphere, actually they're not we should kind of go this, it's not flat. They're like a spherical, as in like a ball. So they've got, it's not just a circle, but you know, from our perspective, they might look like a circle. And then they've got from E0 to E7, and there's a mathematical equation that you have to use to determine this. And we have an activity in class that you're going to be asked to do this. Basically, what you do is you measure A and you measure B. You take 10 times A minus B over A, and that gives you your number. So you just have to measure it. And so you're going to measure this in an activity in class, and you'll get a chance to see how you can categorize these. Okay, and then lastly, there are irregular galaxies. Irregular galaxies are irregular. That means their shape is not defined. They're not a spiral, and they're not an ellipse. All right? So they're just kind of, yeah, that. And we classify them as not like the ear, but irregular. Okay? Okay. Now, Mr. Hubble proposed something called the tuning fork, which we've actually subsequently decided was incorrect, but it is still how we kind of classify the galaxies. Here's our E0, which is he kind of, what his thought was is that the galaxies actually moved through a progression as they changed over time, and then they went to an SA, to an SD, or and he had subcategories. So it turns out that this is something that it's helpful to categorize galaxies, but we don't believe it's what caused the galaxies to change.